So here we're going to have a bit of an introduction to rational expressions. We're going to start off with stuff we already know, skills we've been working on since elementary school, and that's simplifying fractions. And then we're going to see how that changes once we involve some variables in some grade 11 math problems. So we can start off and we know how to simplify problems like this. So we're just wanting to simplify two fractions that are being multiplied together here. If you're multiplying fractions together, then you're just multiplying their numerators and multiplying their denominators. So that means we could rewrite this as 2 times 21 divided by 3 times 14. Well, we could throw this into our calculator and we could do 2 times 21. In fact, we could do that in our heads if we wanted to. But we could alternatively, we could start breaking this down a little bit easier to work with some easier numbers. So if I see a 21 on the top and a 3 on the bottom, I know I can break those down. 21 divided by 3 equals 7. Now, conversely, I see a 14 in my denominator, a 2 in my numerator, and those I can divide out as well. So 14 divided by 2 is 7, leaving me with a 7 in my numerator and a 7 in my denominator. Well, 7 divided by 7, that equals 1. So that's a nice, simple way we can move forward when we're working with fractions if we're multiplying them. Additionally, we'll take just a quick look here. If we're adding something like this, you might be tempted to perform your BEDMAS first, so that means we would need to perform our division before the addition in the numerator, but there are actually some hidden brackets here on the top because it's the entire numerator that's being divided by 8. So we need to perform that addition first. That's 19 divided by 8. I happen to know 19 is a prime number, so I'm not able to reduce this fraction any further. Now, when can we reduce expressions? We can reduce expressions when they involve multiplication and division, and that's right here. Right, we had 2 times 21 in our numerator, 3 times 14 in our denominator. So that's a multiplication happening in numerator and denominator. And because it's a fraction that represents a division operation going on. Whereas over here, I'm not allowed to reduce this. Even though there's a 16 in my numerator and an 8 in my denominator, I might be tempted to divide those out. I can't do that yet because of those hidden brackets. Now, if we need our equation to show multiplication in order to reduce it, that means that we'll need to break our equation down into factors if we're going to do so. So if we're dealing with a problem like, say, this example here, then I have a 4m minus 8 in my numerator. That's something that is a polynomial right now. I do know how to break it down into its factors. I can factor that, and luckily we've been practicing that for a while. I know how to break down my denominator. I can factor that. We've been practicing that for a while. So I'm not going to spend too much time explaining how we factor every single expression in this lesson. You can refer to the previous videos if you're looking for that. We're just going to label them with our factoring strategy. So we'll common factor the numerator. We'll also common factor the denominator down here. We'll common factor out 4 in the numerator, leaving me with m minus 2. And then in my denominator, I can factor out a 2m, leaving me with m minus 2 as well. Now, this is fantastic. I can start canceling things out. So if I start canceling things out, okay, so I know 4 minus 2, that equals 2. I see an m minus 2 factor, right? This entire thing is a factor, and because it's a factor, that's what I can cancel out. So I can cancel the m minus 2 in my numerator and denominator, leaving me with a final answer here of 2 divided by m minus 2. And, 2 divided by m. So if I'm left here with 2 divided by m, then I can ask myself, okay, well, what happens if m equals 2? And actually, let's look at this second question first. What happens if m equals 0? Well, if m equals 0, I could put that into my calculator. That would be 2 divided by 0 here, which if I put into my calculator, it says undefined. Undefined or DNE, and those letters stand for does not exist. And that's because I'm not allowed to divide by 0. So if I'm not allowed to divide by 0, then I need to set myself up here with a bit of a restriction. I need to say, okay, this equation, we're allowed to use it, except this expression, we're allowed to use it, except m cannot be equal to 0. Now, let's take a look at this, so if m equals 0, then our expression does not exist. Now, what about when m equals 2? Well, I could take a look at this final answer, and I could say, okay, if m equals 2, then I would have 2 divided by 2, which I know equals 1. Great. Well, except that's not what I would have found if I'd calculated that from the beginning. So let's try taking a look at it from the beginning, where we were working with 4 times m. So now we're going to use 2 minus 8, all divided by, let's give ourselves a little bit more space here. 4 times 2 minus 8, all divided by 2 times 2 now, squared minus 4 times 2. Okay, well that's 8 minus 8 in my numerator. In my denominator, that's going to be also 8 minus 8, which equals 0 divided by 0. Uh-oh, I don't know what that is. And if I put that into my calculator doesn't know what that is either, because that does not exist, because I'm not allowed to divide by 0. Okay, so now what's going on? Because I'm calculating two different answers depending on where I substitute in 2 for m in my equation. Either at the beginning, I find that it does not exist, or at the end, I find that my expression equals 1. So now I need to try and figure out, okay, what's going on here? I know that what I was trying to do is just reduce my equation so it's easier to look at, but I didn't want to lose out on any information. I didn't want to change my equation. I just wanted to keep writing it in different ways, in more simpler ways for viewing. So keeping that in mind, I need to consider if a certain value for my m, for my variable, caused a does not exist result at the beginning, then I would have needed to have that restriction. So I would have needed to say, okay, from here, m cannot equal 2. Well, how can I know where that 2 is? It just happened to be in the question here, but how can I identify where I can have this restriction? Because I can't look at this expression here, 4m minus 8 divided by 2m squared minus 4m. I can't just look at that and see right away that a value of m equals 2 will create a bunch of confusion in my calculator. So I need to identify, okay, where in this step can I discover that? And it turns out it's in the second step. Before we've performed any cancellations whatsoever, then we have 2 factors in our denominator. We have, 2 factors involving m in our denominator. One of them is this m here, and that one stayed. But the other factor we have is m minus 2. And if I take the root of m minus 2, so if I set m minus 2 equal to 0, and I know that m minus 2 is not allowed to equal 0, right? Because it's a factor of my denominator. So if this factor in my denominator equals 0, it will make my entire denominator equal 0, and that will result in a fraction that's something over 0, and anything divided by 0 is not possible. So m minus 2 is not allowed to equal 0. So I can put a bit of a cross through that equal sign. M minus 2 is not allowed to equal 0, and then I can treat that equal sign, or that inequality sign, just like an equal sign, and I can rearrange to isolate for m. I can add 2 to both sides, so m cannot equal 2, and that's the restriction that they were asking about. So before we perform any cancellations, we can take a look at all of the factors in our denominator, set them equal to 0, and if there's a variable involved, then we can isolate for that variable, and then we can find out any restrictions that are on that variable as we work forward. So that might seem a little bit confusing to you. We'll see it in practice shortly. So we must restrict any variable that ends up in a factor, and that's important because obviously it's only the factors that would get canceled, but it's only if a factor equals 0, that's the only time it becomes a problem. I'm allowed to have a term equal 0 in my denominator. I'm just not allowed to have a factor equal 0. And we call these expressions that we're working with here rational expressions. seeing as we have a polynomial in the involved in the fraction. So let's try this here. Okay, well, before I set my factors in my denominator equal to 0, I need to find out what the factors in my denominator are. In order to do that, I need to factor my denominator. While I'm doing that, I'm also going to factor my numerator at the same time. So I recognize in my denominator a difference of squares. I recognize in my numerator a simple trinomial. So you can factor those using your favorite methods. Let's see here. Like I said, I'm not going to spend too much time on factoring. So I'm left with x minus 5, x plus 3 in my numerator. And in my denominator, x plus 5, x minus 5. So now that it's fully factored, I'm going to look at my restrictions. And looks like I lost some of my question here. There we go. We're trying to simplify the following, and I'll move this over, give us plenty of space here. Good. So we're going to restrict this. I have two factors in my denominator. We need to restrict them both. Let's look at x minus 5 first, because that's the one I am pointing to. X minus 5. So we know x minus 5 is not allowed to equal 0. We can rearrange this, adding 5 to both sides, so x is not allowed to equal 5. Okay, well, let's look at this next one. X, and we'll call that restriction 1. The next one says x plus 5 is not allowed to equal 0. Again, I'm going to rearrange that. Considering my inequality sign, I'm working with that just like I work with an equal sign. So I subtract 5 from each side, bringing me x cannot equal negative 5. Okay, so those are my two restrictions. X cannot equal plus or minus 5. Now that I have those two restrictions, now I'm allowed to perform my cancellations. So I can cancel out x minus 5 because those are factors. I can cancel them out, leaving me with a simplified version, x plus 3 in my numerator divided by x plus 5. And we're always going to write our restrictions again at the end. We're going to try and list them in general, either from least to smallest, or in this case, we can actually work with them together as one. So x cannot equal plus or minus 5. That's a simple way for us to write that. Now, I'm hoping that's relatively straightforward. We'll take a look at actually at two other examples here. Bear with me. Okay, so again, we start off by factoring. We're not able to recognize our factors in the denominator until we've performed the factoring itself. We'll perform factoring in the numerator and the denominator, just like last time. Actually, just like the first time, we see common factoring in the numerator and the denominator. In my numerator, I'm going to common factor out 3x, leaving me with x minus y. In my denominator, I'm going to common factor 5y, leaving me with y minus x. Well, what I recognize here, I have something interesting going on, because I have a factor in my numerator and a factor in my denominator that are very similar, right? They're very similar, but they're not the exact same, so they're almost the same. Sometimes you'll see some factors that look almost the same, but they're different in a way that we can't work with. In this case, they happen to be different in a way that we are able to work with. We have here an x minus y in the numerator, a y minus x in the denominator. If I pay attention to that, if I look really closely, it looks like they're the same, except the signs for both terms are switched around. So the top one has a positive x and negative y. The bottom one has a negative x positive y. So what we can do is we can factor out a negative 1 from either of them, and I'm going to choose the bottom. So I'll factor out a negative 1 value in order to change the sign of the x and the y. So I could rewrite this as 3x over x minus y. So my numerator stays the same, divided by 5y. And then I can, that will become negative y plus x. Okay, well, a better way to write negative y plus x is just x minus y. So that my negative sign doesn't get lost. And this is not only fully factored, but also I can recognize patterns in here. So I will be able to cancel out when I get there, but I can't cancel out yet because I need to state my restrictions. So my restrictions here, again, they come from the denominator, and it's every factor in the denominator. So I see a factor y in the denominator, so that means that y cannot equal 0. That one's relatively straightforward. There's my first restriction. Next, I see an x minus y in my denominator, which tells me that x minus y cannot equal 0. Well, that's another way. The only way x minus y could equal 0 is if x equals y. And in fact, I can find that out by rearranging this here to isolate for x. I can add y to both sides, and I find x cannot equal y as my second restriction. Now that I've stated all of my restrictions, I've checked every single factor in my denominator. Now that I've done that, I can perform any cancellations that I would like to. I see my x minus y term in my numerator and denominator, and I find that this simplifies nice and straightforward. Oops, I forgot the -1 factor down here, and that happens sometimes. We'll forget, but hopefully we can track our mistakes as we work through. Let's change that color so it sticks out nice and obviously for us. Sorry about that, folks. -1. Leaving me with 3x divided by -5y. Now, in general, you will get particularly some picky teachers who always want, because convention in math is to add a negative to have a negative, if you do have one in a fraction, to have it in the numerator. So we're going to put that in the numerator. Our final answer would be -3x over 5y. And again, we would restate the restrictions here. So our restrictions were y cannot equal 0 and y cannot equal x. Fantastic. I could write it out like this, or I could write it as y cannot equal 0 or x. Fantastic. So that looks good. We will do one more here because you might find it useful. So let's check it out. Again, we're going to start off by factoring. And we notice we're working with a complex trinomial in the numerator. We're working with a perfect square in the denominator, just like before. I'm not going to break down the factoring too much. I'm just going to perform it here. So my numerator looks like 2x plus y. My times x minus y. My denominator is a perfect square, like I said. That's x minus y all squared up. Now, since my denominator is 100% factored, I'm going to look at this. Now, you'll notice my denominator is x minus y squared. That is, it has two factors down here, and they're both the same. They're both x minus y. It has the factor x minus y there twice. I don't need to consider the squared when I'm looking at my restrictions. I just need to look at each factor. So the factor is x minus y, and I know that's not allowed to equal 0. I can rearrange this. I performed a similar calculation up above. X cannot equal y. So there's my restriction. Now that I have my restriction, I can perform my cancellations. And x minus y in the numerator cancels out with one of the two in the denominator, leaving me with 2x plus y in my numerator and an x minus y in my denominator. Again, I restate my restrictions. X cannot equal y. Thanks for watching.